So we've looked at multiplying and dividing rational expressions, and we're now going to go ahead and take a look at graphing rational functions. So a rational function is basically a polynomial over a polynomial. In other words, where the top and the bottom are normal polynomials. So in other words, positive whole number exponents on our variables. No fractional exponents, no negative exponents on the variables. So this is a polynomial over a polynomial, so it's a rational function. This is a polynomial over a polynomial. Now, both of these highlight two common things that show up with rational functions. Here, we would have what's referred to as a vertical asymptote. I'll go ahead and draw one in so that you have a better idea of what it's like, which is a vertical line that your purple graph gets close to but never actually touches. And then the other thing that will often happen in a rational function is you'll get what is basically a missing point. We call it a hole in your graph. So as we look here, this one on the right has a vertical asymptote at x equals -2. Actually has a horizontal asymptote, which would be y equals 0, which is a horizontal line that your graph would get close to as you go far to the right and far to the left. And this one over here, as we look at it, if you factor the top and factor the bottom, in this case the bottom doesn't factor, we have a common factor top and bottom. If you have a common factor top and bottom, you have what's referred to as a hole showing up. So if you cross out that common factor, you're only left with an x minus 2, which you know x minus 2 is a diagonal line with a slope of 1 with a y-intercept of -2, which you can see showing up here. And it just happens to be undefined at where that hole is, which is a missing part of your graph. So once again, whenever you have a hole, that means you have a common factor top and bottom, and the hole occurs at what causes that common factor to be 0. After you've crossed out any common factors and you look at what causes the bottom to be 0, that's what causes you to have a horizontal or a vertical asymptote. Now, you could have a horizontal asymptote also. Not all rational functions have a horizontal asymptote, but it's common for them to have it, but not all of them will. So here, we want to find the equation of any vertical asymptotes and any holes. So first of all, you factor the top and the bottom. You'll notice x plus 2 is a common factor top and bottom, so what causes x plus 2 to be 0? Well, when you solve that for 0, you get x to be -2. So in other words, if we cross that out, we're going to have an x minus 2 over an x plus 3. And we're going to just have to graph that, and we'll still have a hole, a missing point in our graph at x equaling -2. We still have variables in the bottom here, so at whatever causes the bottom to be 0 would be your vertical asymptote, which would be -3. So try to do the second problem on your own and then watch the video. Factor the top and the bottom. You have an x plus 3, the same top and bottom, so that means we're going to have a hole at x equals -3 because you set x plus 3 equal to 0 and solve that. You cross out those x plus 3's, you're left with this, so all we have to do is simplify or graph that and just make sure we put a hole, a missing point at x equals -3. We have a vertical asymptote, but what causes this to be 0? You set the bottom equal to 0, and you get x to be -5. So let's go ahead and graph these. First of all, look for any holes. Look for vertical asymptotes. Find your y-intercept, and that's when x is 0, because you're not left and right at all. Find your x-intercept, which is when y is 0, because you're not up and down at all. And then make a t-chart, choosing at least 3 numbers in each side of any holes and vertical asymptotes. So you factor the top and the bottom. In this case, we have no common factors, so we have no holes. You look at what causes the bottom to be 0, so we'd have a vertical asymptote at x equals -1. The y-intercept is 0. Y-intercept is what you get when you plug in 0. So if you plug in 0, you get 0 over 0 plus 1. 0 over 1 is 0. Then you want to find your x-intercept. That's when your y value is 0, so you set it equal to 0 and solve it. And in this case, you also get 0. Normally, they're going to be different. So you want to go ahead and make yourself a t-chart, choosing at least 3 numbers on each side of your vertical asymptote. Then you could go alpha y equals on your newer calculators and type this into as a fraction. If not, put the whole top in parentheses, divide, put the whole bottom in parentheses. And then you get your t-chart. Your calculator will give you an error at -1, and that's once again because that's our vertical asymptote. Then all you have to do is plot your points and sketch in your graph. Here's your vertical asymptote, and your graph would be similar to this. By the way, this one here would happen to have a horizontal asymptote at y equals 1, even though we were not asked to find it. Try to do this problem on your own and then watch the video. Back to the top and the bottom, we have a common factor of x plus 4 top and bottom. So we end up getting just basically y equals x plus 1 with a missing spot in our graph at -4. We know this is a line of y-intercept 1, a slope of 1, and in this case, when you find your x-intercept, you get -1. If you wanted, you could go ahead and make yourself a t-chart, but you're going to have a missing point here. By the way, to find the y value of any hole, you take the x-coordinate of your hole and plug it into your simplified function. If you take -4, plug it in here, you would get -3. You plot these points. We know it's going to be a line. Just make sure you put an open circle at the coordinates of your point, which is -4, -3. Now, just be aware that vertical asymptotes, you can have more than one. Here's a couple graphs where you have 2 of them. You could actually have more than 2. You could have multiple vertical asymptotes, but you could only maybe have one horizontal asymptote, but not everything will have a horizontal asymptote.